Okay, so example 2 looks a little bit more complicated than what we've seen so far. The only difference is that we're dealing with this stuff inside the brackets. To start with, we're going to ignore that stuff inside the brackets. So you can either deal with it there like it is, or you can say, let all that stuff that's inside the brackets actually be represented by something else. So we can use y, you could use m for something completely different. Okay, so then I could say this is actually like 12m squared plus 24m plus 9. Well, that looks more manageable. That looks like a polynomial we've been working with so far. From here, greatest common factor is 3. So we're left with 4m squared plus 8m plus 3. We're going to have to factor that. That's a complex. I'm going to keep those m's red for now, just so we remember that they're kind of out of the ordinary. So I've got 4 and 3. I'm going to do the matrix version this time, pretty similar. So I need 4m squared to show up, and I need positive 3. So it could be 2m and 2m and 3 and 1 maybe. Let's try that out. This would be 6m plus 2m. Well, that gives me 8m, so that works out lovely. So those are my two factors. 2m plus 3 and 2m plus 1. But I'm not done here because those m's are not actually part of my original question. I put them in there, so I got to take them back out. So what actually is it's 3 times 2, x plus 2 goes back in for m plus 3. So I switched to square brackets on the outside. You could have double rounded brackets, that's totally fine. You're more than welcome to do that. I just like to have only one kind of each if possible, or alternating, so that I don't get them confused. From here, I'm gonna have to do a little bit of expanding, a little bit of distribution, a little bit of FOIL, however you want to think about it. And so I end up with 2x plus 4 plus 3 and 2x plus 4 plus 1. Am I done? Not yet, because I've actually got some like terms within those brackets. So I've got 3, 2x plus 7, 2x plus 5. Now you want to be super, super careful, okay? So when we're looking at this, you're only looking for like terms within the brackets. Because remember, order of operations says brackets, exponents, division, multiplication, addition, subtraction. These like terms can only happen within or if there are no brackets. So let's try this one. Again, I'm going to substitute in another letter because it just makes my life a little easier. So it's going to be 3x minus 4, going to be represented by a in this case. So I'm going to have 6a squared minus 21a plus 15. Again, common factors. (21 divided by 3 is 7. 15 is 5. Again, I'm dealing with a complex trinomial. So I'm going to do it my third way now. So I've got 2a squared minus 7a plus 5. Looking for 10 factors that get me negative 7, so that's negative 5 and negative 2. So I'm going to break it up. 2a squared minus 2a. Imagine it's cut in half. Notice I take out the full -5 from this first one, which changes my sign of my second term as well. So I was doing with a minus 1 and 2a minus 5. So that's what I have here. But again, those a's need to get replaced. So I'm going to skip that step. Since I've already got my factored piece written out over on the right-hand side, I'm going to kind of kill two birds with one stone. Instead, I've got 3x minus 4 minus 1 and 2 times 3x minus 4 minus 5. Okay, so those red pieces are coming from over here. Okay, from here it's going to be expand and collect like terms. And so my final answer is going to be 3x minus 5 in this set of brackets. And 6x minus 8 minus another 5 is going to be negative 13, minus 13. And that would be my final answer. Okay, so I know this is getting a little bit more complicated. Please do some practice questions. I really do recommend this substitution method as long as you remember to plug back in. Okay, our third example here is looking at solving quadratics that are differences of squares. So again, differences of squares requires that we have two perfect